beginning section 12.5. This is surface area of pyramids. There is one vocabulary box that we need to do. We need to know what they're talking about if they say slant height. Okay. So if you'll get an index card, we're going to fill this out together. The slant height of a pyramid is the height of one of the lateral faces. Okay. Please pause the video and take a second to take your hand at drawing this. It is an octagonal pyramid. Okay, so do your best. Okay, now that you've got this drawn, let's look at what's labeled here. We've got a pyramid. The base is down at the bottom. Where are your lateral faces of a pyramid? Remember what lateral face means. The lateral face is any face that's not a base. So take a look for a pyramid. What shape is each lateral face? The shape of a lateral face of a pyramid is always a triangle. Okay, because it comes to a point right there at the top at the vertex. So that's going to make a triangle for your lateral face. Okay. The slant height is the height of one of the lateral faces. So if you can really carefully draw in a little dotted line on that triangle, this height represents your slant height. Okay. And one thing that we can say here about extra information, the slant height symbol or variable is a little lowercase l. Why do they let little l represent slant height? I don't know, but this is the common letter in mathematics that represents slant height. Got to be cursive, got to be lowercase. Right here in a non-example, I want you to very carefully, let's draw a triangular pyramid. Let me do a better triangular pyramid here. At a triangular pyramid. What I want you to notice here for the non-example, draw a height or an altitude that goes straight down, kind of like it's going in the middle of this pyramid here, like from that vertex straight to the ground, and it's going to hit right in the middle of the base. This is the actual height of a pyramid. That red piece is not your slant height. Can you see the difference here? Slant height is actually going to be on the lateral face. This is not your slant height because it's kind of like floating in the middle of that pyramid. Okay. All right, so there's your vocabulary box for slant height. As we use it, you're going to see it more. You're going to learn what it is. Okay. Do not take the time to write all this stuff down unless you really want to. That's great. What I want you to utilize this for, you have access to these videos, so at any time when you are working through examples or working through problems, you can come back and find this slide on your video. This is going to be what your thought process should be as you're thinking through how to do these. Okay? Finding the surface area of any polyhedron, here's a flow chart that's just going to help us think through how to solve these problems. Okay? First one, know what you want to find. Is it the total surface area or is it the lateral area? Very important. There's a big difference. Okay. Then we're going to look at what the problem gives us. Okay. Is it giving us the slant height already, or is it going to make us find it? Is it giving us the sides of the bases? Is it giving us the radius of the circle or the diameter? Okay, we've got to know what is it giving us. Think about your formulas that you need when you're thinking about, okay, area, I've got these kind of shapes. Let's look at what shapes we have. What formulas do we need? And then look at the variables that are inside those formulas and find out which variables that you need to plug in. Okay. Next step, after we know the formula and the variables, devise a plan on how to get all the information or all the variables that you need. Okay. Many times you'll have to use Pythagorean theorem or trig, or you may even have to work with circumference and get your diameter, get your radius. They may make you find the variables that you need. You may not just be given them. Here's an important step. Regularly remind yourself of the problem you are trying to answer. Because in geometry, you've got an objective, but there's a lot of puzzle pieces that you have to fill in before your final answer becomes clear. So sometimes we lose sight of where we're going. So at every step that you do, take a second and think about, okay, what am I trying to get in the end? And what do I need this piece for? What am I doing here? That'll kind of keep your mind on track to where you're going. Okay. Finally, after you keep reminding yourself, you got all the stuff that you need, then we can plug it in, then we can add up all the little pieces that we need and solve the problem. Okay. Use this kind of thought process, come back to it, think about these steps as you're working through these problems. Lateral faces of pyramids are what shapes? We already talked about this. Hopefully you can just snap it right off. Lateral faces of pyramids are going to always be triangles. So what area formula are we going to use all over the place here? 1/2 base times height. Here is your area formula for a triangle. Okay. Alright, here we are. Let's go to SGI. This is front side. 12:5. Pause it, find your page. Okay. Looking at number 2, you've got a pyramid. Your pyramid's kind of laying over here. So when you think about the base of this pyramid, your base is that down there. Lateral area are your directions. Now let me slow down just a second and you think about, you are the one doing this, you're given this problem. Always read your directions very carefully. Find the lateral area. Circle keywords if you need to. Find the lateral area of each regular pyramid, or else in the nearest 10. This word regular is important that they threw that in there, because to be regular means that all of the sides of your base is going to be the same size. That's a good thing. That means all these lateral faces are going to be exactly the same size. Okay. All right, so take a look here at number 2. What is the shape of all of your lateral faces? They're triangles. I want to take a second here. This may help you to draw the net. If I set this thing up on its base, and I just draw the base first, how many different triangles am I going to have coming off of that base? Well, if your base is a square, square's got 4 sides, so we have 4 triangles that are going to be the lateral faces of this pyramid. Okay, so you see how we can draw a net to any pyramid. Here it is. Let's put in my dimensions. We need what and what to get the area of a triangle. Okay, here's your thought process. Write down the formula need. Formula for a triangle, 1/2 base times height. That means I need the base and the height of every one of these triangles. My base, look at your picture here, 3.5. That's going to be every side of that square on the bottom. Look at your picture on number 2. It gives you 10 feet right there. Look at that. Isn't that 10 feet your slant height? So when you lay it out flat on the ground here and you look at your triangle, that 10 feet is going to stay with that triangle. That is your slant height. We do need that 10 to plug into your height for your triangle formula. Okay, so here we are. we've got enough information. We plug it into our formula, 3.5 times 10. When you plug this in your calculator, your area is going to be 17.5. That's going to be the area of one of your triangles. If you want the lateral area, then take a look. You have 4 of those triangles. They are all the same shape. Lateral area is all the faces that are not the bases. So this one, this one, this one, this one. Take this number. You have 4 of them. They're all the same size. 17.5 times 4 is going to give you 70. We're still working with area here, so we're going to finish it out with our units, which is feet. Always put a squared on there for area. The lateral area on number 2 is 70 feet squared. Okay. I'm going to extend this number 1 directions for my example here. What if I ask you to find the total surface area? What's the only thing that we need to find to add to it? A pyramid just has this one base on the bottom right here. So can I just find the area of that base and then add it to my lateral surface area? Boom, we got the answer. Take a look at your base. What are the dimensions here? This is a square base, 3.5 by 3.5. So when you do that, your area for this little piece is 12.25. Take this, add it to your 70 that you already have. 82.25 feet squared is your total surface area for this pyramid. Okay. Again, it did not ask you for total, it just asked you for the lateral area. I changed it just a little bit because when you get over to the back side of SGI, it is going to ask you for the total surface area. Find your lateral area first, add on the base area to that number for your total.